Hey there, and welcome to Sleepy Facts. I'm so glad you're here tonight. Maybe you've been searching for calming facts to help you unwind. Maybe you're tired of counting sheep and you'd rather explore the cosmos from the comfort of your bed. Or perhaps you simply enjoy falling asleep to the quiet wonder of astronomy facts. Whatever brought you here, you're in the right place. Tonight, we're taking a gentle journey through our home in the universe, the Milky Way galaxy. No rush, no stress, just calm exploration. You don't need to remember everything. In fact, you don't need to remember anything at all. Just let the words wash over you like gentle waves. Let your breathing slow. Let your muscles relax. Let gravity feel just a little bit softer. We'll drift through 2 full hours of the most peaceful space facts you've ever heard. From ancient stars older than time itself, to quiet cosmic mysteries that even scientists are still puzzling over, some facts might surprise you. Others might make you smile softly in the darkness. Most will simply help your mind settle into that perfect state between waking and dreaming. Take a moment now to adjust your pillow. Find that perfect position where your body feels supported. Notice how your weight sinks into the mattress. Feel the warmth of your blanket, the coolness of the air against your face. These small sensations anchor you in this moment of rest. There's something profound about contemplating the cosmos as you drift towards sleep. Our daily worries feel smaller when measured against billions of years. Our anxieties seem less urgent when set against the backdrop of infinity. The universe has been here for 13.8 billion years. It will be here long after we're gone. And somehow, that's not frightening. It's comforting. Before we begin our journey through the stars, if these sleepy science facts help you rest better, consider giving this video a like. It helps other tired souls find their way here too. And if you'd like more bedtime facts for adults, subscribe to Sleepy Facts. We're here every week with new calm content designed specifically for better sleep. Now let your eyes close if they want to. Get comfortable. Pull your blanket a little closer. Take 3 slow, deep breaths. Breathe in through your nose for 4 counts. Hold for 4. Release through your mouth for 6. Feel your shoulders drop. Feel your jaw unclench. Feel the day beginning to dissolve. And let's begin our slow drift through the Milky Way, our ancient, spiraling home among the stars. A galaxy of secrets and silence, of light that has traveled for millennia just to reach your eyes, of mysteries that will outlast all human memory. We start here together, floating in the darkness, ready to explore, ready to rest. The galaxy's ancient story. The Milky Way is over 13 billion years old. Our galaxy has been turning through space for an almost unimaginable length of time. Over 13 billion years. That's nearly as old as the universe itself. When the Milky Way first began to form, the cosmos was still young and wild. There were no planets yet. No complex elements, just clouds of hydrogen and helium slowly gathering under the gentle pull of gravity, condensing in the darkness like morning dew on invisible webs. Try to imagine it. 13 billion years. If you counted 1 year per second, it would take you over 400 years just to count to 13 billion. Every human civilization that has ever existed, from the first farmers in Mesopotamia to the present day, represents less than 1/1,000,000th of the galaxy's lifetime. We are newcomers, recent arrivals in an ancient home. Over billions of years, those primordial clouds collapsed, stars ignited, generations were born and died. And slowly, patiently, the beautiful spiral we call home took shape. The galaxy you're resting in tonight has witnessed nearly the entire story of creation. It remembers in its structure what the early universe was like. The Milky Way has seen the birth of trillions upon trillions of stars. It has watched countless worlds form and dissolve. It has been shaped by collisions with smaller galaxies, each merger adding new stars to its population, new streams of light to its halo. And through it all, it has continued turning, slowly, steadily, like a vast cosmic clock marking the passage of eternity. The Milky Way wasn't always a spiral. If you could travel back in time 10 billion years and look at our galaxy, you might not recognize it. The neat spiral arms we imagine today didn't exist yet. The Milky Way was more chaotic then, smaller, lumpier, still gathering itself from the scattered debris of early star formation. Picture a vast, irregular cloud, pockets of stars glowing here and there, streams of gas flowing inward. No clear structure, no defined shape, just gravity slowly, patiently pulling everything together, like clay spinning on a potter's wheel, not yet formed into its final shape. The spiral structure formed gradually as the galaxy settled into rotation. Like water swirling down a drain, the stars and gas began to organize into those graceful curved arms. It took billions of years of slow, patient turning. Millions of orbits, countless generations of stars being born, living, dying, and enriching the next generation with their remnants. Even now, the spiral isn't finished. It shifts slightly with each passing million years, responding to gravity, to dark matter, to the gentle push and pull of neighboring galaxies. The Milky Way is always becoming, never quite complete. Like everything in the universe, it is a process, not a product, a verb, not a noun. The spiral arms you might glimpse on a clear night in the countryside, that river of light arcing across the sky, represents just one moment in the galaxy's endless transformation. In another billion years, the arms will have shifted. New stars will blaze where now there is darkness. Old stars will have faded where now there is light. The galaxy remakes itself endlessly, across spans of time too vast for human minds to truly grasp. Some stars are older than the galaxy itself. This might sound impossible, but scattered throughout our galaxy are stars that formed before the Milky Way finished assembling itself. They're called halo stars, and they drift in long tilted orbits high above and below the main disk. These ancient wanderers were likely born in smaller primitive galaxies that merged with ours billions of years ago. When those little galaxies were absorbed, consumed in slow-motion collisions that took hundreds of millions of years to complete, their stars remained. Now they orbit in paths that don't quite match the rest of the Milky Way's motion. They're like immigrants from foreign lands, carrying memories of homes that no longer exist. They're incredibly old. Some contain almost no heavy elements at all, just hydrogen and helium from the Big Bang. Looking at them is like looking at cosmic fossils. They remember a universe that was younger, simpler, stranger than the one we know today. A universe before carbon, before oxygen, before iron. A universe that couldn't have supported life as we know it. In their dim, steady light, we glimpse what came before. They are the elders of our galactic home, silent witnesses to everything that followed. When you look up at the night sky, know that among those points of light are stars that have been shining since before the Earth existed, before the sun existed, before the solar system was even a cloud of dust. They are older than almost everything you can name, and yet they continue burning, steady and patient in their ancient orbits. Take a slow breath. Feel your chest rise and fall. The oxygen you just breathed was made in stars like these. Not these exact stars, but stars like them from an earlier generation. They lived, they died, they scattered their atoms into space, and eventually, billions of years later, some of those atoms found their way into you. You are breathing stardust. You are made of ancient light, the galaxy's invisible architecture. Dark matter holds everything together. Here's one of the most profound mysteries in all of science, and it's strangely calming when you think about it. The Milky Way shouldn't exist. Not as we see it anyway. If you add up all the mass we can see, every star, every planet, every cloud of gas and dust, there isn't enough gravity to hold the galaxy together. The outer stars are spinning so fast, they should have been flung into space billions of years ago, scattered like water drops from a spinning wheel, and yet they remain. They orbit steadily, calmly, as if held by invisible hands, as if something we cannot see is keeping them in place. And that's exactly what's happening. The answer is dark matter, a mysterious substance that doesn't emit light, doesn't reflect it, doesn't interact with ordinary matter in any way we can directly observe. It passes through walls, through planets, through you, without leaving a trace. And yet, it has gravity. Enormous amounts of it. Dark matter surrounds the Milky Way in a vast halo, outweighing all the visible stars and gas by perhaps 10 to 1. It is the galaxy's hidden scaffolding, the unseen foundation that keeps everything in place. Without it, the spiral would have flown apart long ago, scattering into the void. We owe our existence to something we cannot see, or touch, or measure directly. We don't know what dark matter is made of. Physicists have proposed dozens of candidates' exotic particles with names like WIMPs and axions, but none have been detected yet. We can't see it or touch it. We only know it's there because of what it does. It holds the galaxy together with a gentle, patient grip. Like an invisible embrace that's lasted billions of years. There's something comforting about that. The universe contains mysteries we may never fully solve. And yet those mysteries are part of what makes our home possible. We live in a cosmos that exceeds our understanding. That doesn't make it less real. It makes it more wondrous. Right now, as you lie in bed, dark matter particles are streaming through your body. Billions upon billions of them every second. They pass through the Earth itself as if it weren't there. They came from the halo of the galaxy, passed through your room, through you, and will eventually exit the other side of the planet, continuing on their journey through space. You are swimming in an invisible sea. You always have been. You always will be. Let that thought settle gently in your mind. The universe is stranger and deeper than it appears. What we can see is only the beginning, and that's perfectly okay. We don't need to understand everything to rest. We don't need answers to every question to find peace. Sometimes mystery itself can be a kind of comfort. Most of the galaxy's mass is outside the disk. When we picture the Milky Way, we imagine the bright spiral disk, glowing with billions of stars. And that's certainly the most visible part. But it's not where most of the mass resides. The galaxy is surrounded by an enormous, nearly invisible halo. This halo extends far beyond the furthest stars we can see, perhaps hundreds of thousands of light years out into the darkness. It's made mostly of dark matter, along with some very old, very faint stars and ancient globular clusters. This halo is so diffuse, so spread out, that if you were inside it, you might not notice anything at all. Just vast, empty darkness, with the occasional ancient star drifting past every few thousand light years, like floating in an ocean at midnight, unable to see the water around you, aware only of the occasional distant light. But collectively, that halo contains most of the Milky Way's mass. The bright disk we see is almost like the visible tip of an enormous iceberg. Beneath it, or rather around it, lies something much larger and far more mysterious. It's a reminder that what we see is only a small fraction of what exists. The universe is deeper than appearances suggest, and sometimes the most important things are the ones we cannot see. Imagine standing on the shore of a dark ocean at night. You can see the waves nearby, glinting in moonlight. But the vast depths below, the enormous volume of water stretching for miles in every direction that remains hidden. The Milky Way is like that ocean. We see the surface. We see the bright foam and sparkle. But most of it exists in realms we cannot directly perceive. And that's all right. Mystery is part of the structure of reality. Uncertainty is woven into the fabric of existence. The Milky Way is wrapped in a magnetic field. Another invisible structure threads through our galaxy, a vast magnetic field that weaves through the spiral arms, rises into the halo, and traces patterns we're only beginning to understand. This field is incredibly weak by everyday standards. Earth's magnetic field is thousands of times stronger, but spread across the enormous distances of the galaxy, even a weak field has profound effects. It shapes how gas flows between the stars. It guides cosmic rays on their billion-year journeys through space. It influences where and how new stars form, gently steering the collapse of massive clouds. Radio telescopes can map this field by watching how it affects the light passing through it. The patterns they reveal are intricate, complex, almost organic looking. loops and arcs and spirals within spirals, like neural pathways in a vast cosmic brain. The galaxy doesn't just shine with light, it hums with magnetism, an invisible current flowing through its structure like blood through veins, another hidden layer to the cosmos, working quietly in the background while stars burn and planets turn. You cannot see magnetic fields with your eyes. You cannot touch them or taste them, but they're real. They shape the universe. They connect distant regions of space. They make certain things possible and other things impossible. Take another slow breath. Feel your body sinking deeper into rest. The layers of invisible structures surrounding the galaxy, the dark matter halo, the magnetic field, the streams of particles and radiation, all exist whether we perceive them or not. Reality is vaster than our senses. The universe operates on scales both smaller and larger than we can directly experience. And yet we're part of it, connected to it, made from it. Even the electrical signals firing in your brain right now, allowing you to process these words, are electromagnetic in nature. You are part of the web. You always have been. The galaxy in motion. Our solar system orbits at 828,000 kilometers per hour. Right now, as you rest quietly in bed, you're moving through space at an almost incomprehensible speed. The Earth rotates on its axis at about 1,600 kilometers per hour. It orbits the Sun at roughly 107,000 kilometers per hour. But those speeds are small compared to how fast the entire solar system is moving through the galaxy. Our Sun, along with all its planets, is racing around the Milky Way's center at more than 828,000 kilometers per hour. That's about 230 kilometers per second. Faster than most bullets. Faster than anything humans have ever built. And yet you feel nothing. No wind in your face. No sense of motion. Because everything around you, the air, the ground, the buildings, is moving with you. You're part of a vast cosmic dance, spinning through the galaxy at impossible speeds. And it feels like perfect stillness. This is what relativity means in the most practical sense. Motion is relative. Without a fixed reference frame, without something stationary to compare against, even tremendous speeds feel like rest. It takes our solar system approximately 225 to 250 million years to complete one full orbit around the galactic center. That's called a galactic year, or a cosmic year. Since the Sun formed about 4.6 billion years ago, it has completed roughly 20 orbits, 20 trips around the galaxy, 20 times circling through the spiral arms, passing through dense regions and empty regions, witnessing the slow evolution of our neighborhood in space. The last time the Sun was in this same position in its orbit, dinosaurs roamed the Earth. The time before that, the first complex multicellular life was just beginning to evolve in ancient seas. The time before that, Earth was a barren world with only primitive microbes clinging to existence. Each orbit represents an unimaginable span of history, and through it all, the Sun has continued its patient journey, never stopping, never slowing, always moving through the galaxy's great wheel. The spiral arms are not solid objects. When you see images of spiral galaxies, it's easy to imagine the arms as rigid structures, like the arms of a spinning pinwheel. But they're not solid. They're more like traffic jams. As stars orbit the galactic center, they sometimes bunch up in certain regions, creating areas of higher density. These are the spiral arms. Stars enter them, slow down slightly as they move through denser regions, then exit on the other side and continue on their way. Think of a highway during rush hour. Cars bunch up in certain areas, creating waves of slower traffic. Those waves can persist even as individual cars enter and exit them. The traffic jam moves along the highway as a wave, even though the cars themselves are just following their own routes. Spiral arms work the same way. They're density waves moving through the galaxy. Stars and gas clouds pass through them, spend some time in the denser environment, then emerge on the other side. Our Sun is currently between spiral arms, in a relatively quiet region called the Orion Spur. This might be fortunate. The spiral arms are where most of the violent energetic activity happens, where massive stars are born and quickly die in supernovae, where radiation levels are higher, where the risk of encountering dangerous cosmic events increases. We live in a suburban neighborhood of the galaxy, not too close to the bright, chaotic center. not too far out in the lonely outskirts, just right for the slow development of life. The galaxy is gently bobbing up and down. As the solar system orbits the galactic center, it doesn't stay in a flat plane. It oscillates up and down through the galactic disk, like a horse on a carousel. We're currently about 75 light-years above the midplane, moving upward. Eventually, we'll reach a peak height of about 250 light-years above the disk, then fall back down, pass through the midplane, continue downward to about 250 light-years below it, and then rise again. This up and down motion takes roughly 60 to 70 million years to complete one full cycle. We cross through the densest part of the galactic disk, the midplane, about once every 30 to 35 million years. Some scientists have speculated that this periodic crossing might correlate with extinction events on Earth. As we encounter higher densities of matter, more radiation, and perhaps increased comet impacts from gravitational disturbances. But the evidence remains uncertain. What's clear is that we're part of a multi-layered dance, orbiting, oscillating, spinning through space on multiple axes simultaneously. Let that motion settle in your mind. You are moving in so many ways, rotating with the Earth, orbiting with the Earth around the Sun, traveling with the Sun around the galaxy, bobbing up and down through the galactic plane. And the galaxy itself is moving through space, falling toward the Virgo supercluster, along with our local group of galaxies. Motion within motion within motion. And yet, here you are, perfectly still in your bed, feeling nothing but quiet peace. All that movement, all that cosmic choreography, and you experience perfect stillness. It's one of the beautiful paradoxes of existence. Life cycle of stars. Stars are born in clouds of gas. Every star you see began as a cloud, vast nebulae of hydrogen gas, drifting through space, so thin that millions of miles of it contain less mass than a breath of air. But gravity is patient. Over millions of years, these clouds slowly contract. The gas falls inward, pulled by its own weight. As it falls, it heats up. The center grows denser, hotter, more compressed. Eventually, the temperature and pressure become so extreme that hydrogen atoms begin to fuse into helium. Nuclear fusion ignites. A star is born. What was darkness becomes light. What was cold becomes a furnace. And the galaxy has one more point of brilliance in its collection. The first light from a newborn star must fight its way out through the surrounding cocoon of gas and dust. For a while, the star remains hidden, wrapped in its birth cloud. But eventually, the intense radiation and stellar winds from the young star blow away the remaining material. The cloud disperses, and suddenly, where there was only darkness, there's a new point of light in the sky. A star has joined the galactic community. It will shine for millions or billions of years, depending on its mass. And then, eventually, it too will die, returning its material to space so that future generations of stars can form. Most stars live quietly for billions of years. After the dramatic birth, most stars settle into a long, peaceful existence. They burn their hydrogen steadily, maintaining a perfect balance between the inward pull of gravity and the outward push of fusion. This phase can last billions of years. Our sun is middle-aged, about 4.6 billion years old, with another 5 billion years of stable burning ahead of it. Imagine that lifespan: 5 billion years of steady light, 5 billion years of patience, 5 billion years of simply being, doing what stars do, turning mass into energy, warming whatever planets happen to orbit nearby. During this time, the star changes very little. Its temperature stays roughly constant. Its brightness fluctuates only slightly. It's a period of extraordinary stability, and that stability is what makes life possible. If stars were more variable, if they brightened and dimmed unpredictably, planets would freeze and thaw in chaotic cycles. Complex chemistry would be impossible. Life as we know it couldn't develop. We owe our existence to the fact that stars are reliable, that they burn with such patient consistency for such vast stretches of time. Red giants swell to enormous sizes. Eventually, every star runs out of hydrogen in its core. For stars like our sun, this is when things start to change. The core contracts under gravity, growing hotter and denser. This triggers hydrogen burning in a shell around the core. The energy from this shell burning causes the star's outer layers to expand dramatically. The star swells up to hundreds of times its original size, becoming what we call a red giant. Its surface cools, giving it a reddish color, but its total light output actually increases because it's so much larger. When our sun becomes a red giant in about 5 billion years, it will expand beyond Earth's current orbit. Mercury, Venus, and possibly Earth will be engulfed, their surfaces vaporized, their atoms incorporated back into the star that once warmed them. It's a sobering thought, but also in a way, a beautiful one. Everything returns, everything cycles. The atoms that make up Earth will one day become part of the sun again. And later, when the sun sheds its outer layers as a planetary nebula, those atoms will drift back into space, ready to form new worlds, new stars, new possibilities. White dwarfs are the quiet endings. For stars like the sun, the end is peaceful. After the red giant phase, the star gently puffs off its outer layers, creating a glowing shell of gas called a planetary nebula. What remains is the hot, dense core, a white dwarf. No larger than Earth, but containing about half the sun's mass. Incredibly dense. A teaspoon of white dwarf material would weigh as much as an elephant on Earth. These remnants no longer undergo fusion. They simply radiate away their stored heat over trillions of years, slowly cooling, slowly fading, until eventually they become cold, dark stellar corpses called black dwarfs. But here's something interesting. The universe isn't old enough yet for any black dwarfs to exist. Even the oldest white dwarfs, formed in the early days of the galaxy, are still glowing faintly. They're cooling, yes, but it takes an almost incomprehensibly long time for them to radiate away all their heat. Tens of billions of years, possibly hundreds of billions. The first black dwarfs won't appear until long after the last regular stars have died. They'll be the final embers of stellar light, cooling in a universe that has grown cold and dark. Massive stars explode as supernovae. Stars much more massive than the sun end differently. They burn through their fuel quickly, sometimes in just a few million years, and undergo a series of dramatic transformations. After exhausting their hydrogen, they start fusing helium into carbon and oxygen, then carbon into neon and magnesium, then neon into oxygen and silicon. Each stage produces heavier elements and releases less energy. Eventually, the core becomes iron, and iron cannot be fused to release energy. It's the end of the line. With no fusion to support it, the iron core collapses in a fraction of a second. The collapse is catastrophically fast and violent. The core's temperature skyrockets to billions of degrees. The density becomes so extreme that protons and electrons are crushed together to form neutrons. And then, suddenly, the collapse halts. The compressed core rebounds, sending a shockwave outward through the star. This shockwave rips the star apart in a supernova explosion, one of the most energetic events in the universe. For a few weeks, a single supernova can outshine an entire galaxy. That explosion scatters all the elements the star created during its lifetime out into space. Carbon, oxygen, silicon, iron, and heavier elements forged in the explosion itself. Gold, silver, uranium, all of it expelled at tremendous speeds, mixing with the interstellar medium, seeding future generations of stars and planets with the raw materials for complexity. Every atom of oxygen you breathe, every atom of carbon in your body, every atom of iron in your blood, all of it came from stars that exploded billions of years ago. You are made of supernova debris. You are stitched together from stellar catastrophes. And isn't that remarkable? That destruction creates the possibility for future creation. That death makes room for new life. Neutron stars are the densest objects. After a massive star explodes, what's left of the core might become a neutron star, an object about 20 kilometers across but containing more mass than the sun. The density is almost beyond comprehension. A single teaspoon of neutron star material would weigh about 1 billion tons. That's more than all the cars on Earth combined, compressed into a teaspoon. The gravity is so intense that light is visibly bent as it passes nearby. Time itself runs slower on the surface of a neutron star compared to here on Earth. Some neutron stars spin incredibly fast, rotating hundreds of times per second. They emit beams of radiation from their magnetic poles. And if those beams happen to sweep across Earth, we detect regular pulses of light or radio waves. We call these objects pulsars. They're like cosmic lighthouses, spinning in the darkness, their beams flashing with metronomic precision. Some pulsars are so regular, they rival atomic clocks in their timing. They're the most accurate, naturally occurring timekeepers in the universe. Steady, reliable, rotating in the darkness, long after the stars around them have changed or died. Black holes are where stars disappear. For the most massive stars, even a neutron star isn't the final state. If the collapsing core has too much mass, nothing can stop it. Not even the pressure of neutrons packed together. The collapse continues. The core shrinks past the neutron star stage. It keeps collapsing, compressing, concentrating, until finally it collapses completely into a singularity. A point of infinite density surrounded by an event horizon, a black hole, a place where gravity is so strong that not even light can escape, where time stops, where the normal rules of physics break down into something we don't yet understand. Black holes are strange objects, terrifying and fascinating in equal measure. Once something crosses the event horizon, it can never come back. It's gone from our universe forever, falling toward the singularity in a journey that, from the outside, seems to take infinite time. But from the perspective of someone falling in, it happens quickly. You'd cross the horizon barely noticing it, then be torn apart by tidal forces as you approached the singularity. Spaghettification, scientists call it. Your body stretched into a long, thin strand by the difference in gravitational pull between your head and your feet. But here's something to ease that dark thought. Black holes are far away. The nearest one is thousands of light years distant. They're not monsters stalking through the galaxy, consuming everything. They're just objects with very strong gravity, sitting quietly in space. Most of them were once massive stars. They lived, they burned, they ran out of fuel, and they collapsed. It's not evil or malevolent. It's just physics. Just the final chapter in a particular kind of stellar story. And even black holes won't last forever. They slowly evaporate through a quantum process called Hawking radiation. Given enough time, trillions upon trillions of years, even the black holes will fade away, leaving behind only radiation and memories. Constellations and mythology. Ancient cultures saw rivers in the sky. Long before we understood what galaxies were, humans looked up at the Milky Way and told stories about it. The ancient Greeks called it Galaxias Kyklos, the Milky Circle, and believed it was milk spilled from the breast of the goddess Hera. According to the myth, Zeus wanted his mortal son Hercules to become immortal, so he placed the infant at Hera's breast while she slept. When she woke and pulled away, milk sprayed across the sky, creating the Milky Way. It's a beautiful story, a cosmic accident that created something magnificent. In Norse mythology, it was called Bifrost's shadow, or the path to Valhalla, the road that warriors' souls would travel after death. They imagined fallen heroes walking that glowing path across the night sky, heading toward eternal feasting in Odin's hall. Chinese astronomers called it the Silver River, a celestial waterway that divided the sky. According to legend, it separated two lovers, the weaver girl and the cowherd, who could only meet once a year when a bridge of magpies formed across the river. The ancient Egyptians saw it as a reflection of the Nile, flowing through the heavens just as the earthly Nile flowed through their land. Each culture wove the Milky Way into their cosmology, trying to make sense of that luminous band stretching across the night. They didn't know they were looking at hundreds of billions of stars, so distant they blurred together into a pale glow. They didn't know they were seeing their own galaxy from the inside, but they knew it was important. They knew it was sacred. They knew it connected them to something larger than themselves. In a way, their intuition was correct. The Milky Way does connect us to something larger. Not to gods or heroes, perhaps, but to the vast community of stars that make up our galactic home. To the generations of stars that lived and died to create the elements in our bodies. To the slow processes of cosmic evolution that made our existence possible. The stories were different, but the sense of connection was real. Constellations are cultural constructs. When you look up at the night sky and see constellations Orion, Ursa Major, Cassiopeia. You're seeing patterns imposed by human imagination. The stars themselves aren't actually connected. They're at vastly different distances from us. Some are relatively nearby. Others are thousands of light years away. They only appear to form patterns because we're viewing them from this particular vantage point, from this particular moment in cosmic time. From another angle or another era, the patterns would look completely different. And yet, for thousands of years, humans have used these patterns to navigate, to mark the seasons, to tell time and to tell stories. Different cultures saw different patterns in the same stars. The Greeks saw a great bear in Ursa Major. Native Americans saw a celestial bear being chased by hunters. Chinese astronomers saw part of an emperor's palace. Same stars, different stories. All equally valid as ways of making meaning from the cosmos. There's something beautiful about that. The universe doesn't come prepackaged with meaning. We create the meaning. We draw the lines between stars. We invent the stories. And those stories help us remember, help us navigate, help us feel connected to the sky above us. The constellations are human art projected onto the cosmos. They're how we turn the random scatter of stars into something familiar, something comforting, something that feels like home. The Milky Way inspired creation myths. In many cultures, the Milky Way played a central role in creation myths. The Aboriginal peoples of Australia have a tradition called the emu in the sky, where they see the dark dust lanes of the Milky Way as forming the shape of a giant emu. This emu is connected to stories about the creation of the world and the laws that govern human behavior. They saw the galaxy not just as decoration, but as an active participant in the structure of reality itself. The Cherokee people of North America have a story about the Milky Way being created by cornmeal, spilled by a dog stealing from a storehouse. The dog ran across the sky, leaving a trail of meal behind it, which became the glowing path we see at night. In Hindu cosmology, the Milky Way is sometimes described as the light from the god Shiva's celestial city. In Zoroastrian tradition, it represented the seam of the sky, the place where heaven was stitched together. These stories remind us that humans have always looked up and wondered. We've always tried to connect what we see in the sky with what we experience on Earth. We've always sought patterns, meaning, narrative. The modern scientific understanding of the Milky Way, that it's a spiral galaxy containing hundreds of billions of stars, is just the latest chapter in a long tradition of humans trying to understand their place in the cosmos. Our ancestors didn't have telescopes or spectrographs, but they had imagination. They had curiosity. They had the same urge we have to look up and ask, what is that? What does it mean? How does it relate to us? Take a moment to rest in that continuity. You're part of an unbroken chain of humans looking up at the night sky. Your ancestors saw the same Milky Way you see, albeit with different eyes, different understanding. And your descendants, if they look up from wherever they happen to be, will see it too. Changed, yes, shifted slightly by the slow drift of stars, but still there, still glowing, still that luminous band arcing across the darkness. You're connected to every human who has ever wondered about the stars. Across time, across cultures, across the vastness of history, cosmic scale comparisons. If the Milky Way were the size of Africa, it's almost impossible to comprehend the true scale of the Milky Way. So let's shrink it down. Imagine the entire galaxy compressed to the size of the African continent, about 30 million square kilometers. Now, on that scale, our entire solar system, from the Sun to the orbit of Neptune, would be smaller than a grain of sand. Not a pebble, not a marble, a single grain of sand. And Earth itself? Earth would be invisible to the naked eye, a speck on a grain of sand on a continent. That's how vast the galaxy is compared to our home. And yet, even at that scale, the nearest star to our sun Proxima Centauri would still be several millimeters away from our grain of sand. Space is mostly empty, mostly silence, mostly darkness. The stars are scattered so far apart that even traveling at the speed of light, the fastest anything in the universe can go, it would take years to reach the nearest ones. We live in an ocean of emptiness, dotted with tiny islands of matter and light. Light takes 100,000 years to cross the galaxy. Light is fast, unimaginably fast by human standards. It travels at about 300,000 kilometers per second. In 1 second, a beam of light could circle the Earth 7.5 times. In 1 year, light travels about 9.5 trillion kilometers, a distance we call a light year. It's our preferred unit for measuring cosmic distances because kilometers and miles become absurdly large numbers when dealing with the spaces between stars. The Milky Way is about 100,000 light years in diameter. That means if you turned on a flashlight at one edge of the galaxy and pointed it toward the other side, the light would take 100,000 years to arrive. Let that sink in. Light, the fastest thing in the universe, needs 100,000 years to cross our galaxy. If an alien civilization on the far side of the Milky Way were to send us a message traveling at light speed, we wouldn't receive it for 100,000 years. And if we replied immediately, they wouldn't hear back for another 100,000 years. That's how vast even our local cosmic neighborhood is. When you look at a star that's, say, 1,000 light years away, you're seeing it as it was 1,000 years ago. The light that's hitting your eyes tonight left that star during the Middle Ages on Earth. When you look at the galactic center, you're seeing it as it was 26,000 years ago, before recorded human history began, before agriculture, before civilization. The galaxy you see in the sky is a ghost, a memory of how things were, not how they are now. If the sun were a grain of sand, here's another way to think about scale. If the sun were reduced to the size of a grain of sand, Earth would be a speck of dust about 2 meters away. Jupiter would be a small pebble about 10 meters away. Neptune, the outermost planet, would be another small grain about 60 meters away. That's our solar system on that scale, spanning about the length of a basketball court. And the nearest star? Still over 500 kilometers away. You'd need to place another grain of sand representing Proxima Centauri more than 500 kilometers from your original sun grain to represent the distance accurately. Now imagine filling that 500-kilometer gap with more grains of sand, each one representing a star, spaced at similar distances. That's just our immediate neighborhood. To fill the entire galaxy at that scale, you'd need to cover an area the size of the Atlantic Ocean with grains of sand, each separated by hundreds of kilometers. The mind rebels at these scales. We didn't evolve to think in such terms. Our brains are built for navigating forests and plains, for judging the distance to prey or predators. We're not built to comprehend light years and billions of stars. And yet, here we are, trying anyway, using analogies and comparisons and mathematical tools to extend our understanding beyond what our intuition can grasp. It's one of the remarkable things about human consciousness. We can think about scales far beyond our direct experience. We can model the cosmos in our minds, even though we're confined to a single tiny planet. We can trace the structure of the galaxy, even though we'll never see it from the outside. We use reason and imagination to transcend our limitations, and in doing so, we touch something vast. The observable universe contains trillions of galaxies, and the Milky Way itself, vast as it is just one galaxy among countless others. Current estimates suggest there are at least 2 trillion galaxies in the observable universe, each one containing hundreds of billions of stars, each star potentially hosting planets. The numbers become meaningless through sheer magnitude. 2 trillion galaxies? That's more galaxies than there are stars in the Milky Way. Try to picture that. Every point of light in our galaxy, replaced by an entire galaxy, that's the scale of the cosmos beyond our home. And remember, that's just the observable universe, the part we can see from here. There's likely much more beyond the horizon of our observations, regions so far away that their light hasn't had time to reach us yet. The universe might be infinite, or it might curve back on itself, or it might be one of many universes in a larger multiverse. We don't know, and maybe we'll never know, but we can appreciate the vastness of what we can see and find a strange comfort in our smallness. We are tiny, infinitesimally tiny against the backdrop of all that exists. And yet we're part of it, made from it, connected to it in ways both physical and poetic. Meditative interlude, breathing with the cosmos. Let's pause here for a moment, not to add more facts, not to explore more mysteries, just to breathe, to rest in the silence between words. Inhale slowly, as if drawing in starlight. Hold that breath for a moment. feeling the oxygen circulate through your blood, oxygen created in ancient stars, now flowing through your body. Then exhale, releasing whatever tensions remain. Let them dissolve like nebulae, scattering into space. Inhale again. This time, imagine you're breathing in the age of the galaxy. 13 billion years of history, condensed into a single breath. Feel that vastness fill your lungs. Feel how small your worries become in comparison. Hold that breath. Feel the weight of cosmic time. And then release. Breathe out your anxiety. Breathe out your stress. Let it drift away into the darkness, insignificant against the backdrop of eternity. Your concerns are real, but they're also temporary. Brief ripples in an endless ocean. One more time. Breathe in peace. Breathe in silence. Breathe in the knowledge that you are part of something ancient and endless. You are made of atoms, forged in the hearts of dying stars. You are a pattern of stardust, briefly aware, briefly thinking, briefly here. And that's enough. Hold that breath. Feel that truth settle in your chest. You don't need to be anything more than you are. You don't need to accomplish anything. You don't need to prove anything. You're already part of the cosmos. You're already connected to everything. And let it go. Release. Relax. Rest. Notice how your body feels now. Maybe your shoulders have dropped a little. Maybe your jaw is less clenched. Maybe your breathing has naturally slowed. These are good signs. Your nervous system is shifting into rest mode. Your body is preparing for sleep. Let that process continue. Don't force it. Just allow it. Like a leaf falling from a tree, you're descending gently towards sleep. No effort required. Just presence. Just acceptance. Just letting go. The galaxy doesn't effort. It simply is. Stars don't try to shine. They shine because that's their nature. Planets don't try to orbit. They follow the curves of space-time because that's what matter does. You don't need to try to sleep. You just need to stop resisting it. Stop trying to control your thoughts. Stop analyzing whether you're doing it right. Just be, like a star, like a planet, like a galaxy turning through space. Just exist in this moment, breathing, resting, letting the day dissolve behind you. Imagine yourself floating in space, weightless, supported by nothing and everything at once. Around you, stars shine with gentle, steady light. They're not harsh, not bright enough to hurt your eyes. Just soft points of luminescence in the comfortable darkness. You're drifting among them, peaceful, safe, part of the cosmic dance. There's no up or down, no past or future, just this eternal now. This moment of floating in the galaxy's embrace. And as you float, you realize you're not separate from the stars. You're made of the same stuff. The atoms in your body and the atoms in those distant suns share the same origin, same history, same fundamental nature. You're not observing the cosmos from outside. You're part of it. You've always been part of it. And you always will be, even after this particular arrangement of atoms that is your body disperses. The universe doesn't lose anything. It only transforms. Energy and matter persist, endlessly recycling, endlessly creating new forms. Let that thought comfort you as you drift deeper towards sleep. You belong here. You're home. You're exactly where you're supposed to be, in a universe that includes you, that created you, that is experiencing itself through you. Rest in that knowledge. Rest in that connection. Rest in the gentle darkness, surrounded by ancient light, part of something vast and beautiful and mysterious. You are safe. You are held. You are part of the eternal dance of matter and energy. And for now, for these next hours, you get to rest, to sleep, to let go completely. Breathe, rest, be. Closing thoughts. The galaxy continues while we rest. Tonight, as you drift off to sleep, the Milky Way continues its slow, patient turning. Stars are being born in clouds of gas. Others are dying in supernovae, or gently shedding their outer layers into space. Cosmic rays stream through the darkness. Neutrinos whisper through the earth, through your body, barely interacting with anything. Gravitational waves ripple outward from distant collisions between black holes or neutron stars. Black holes quietly accumulate matter at their event horizons. Pulsars spin with metronomic precision. Rogue planets drift silently through the darkness between stars. Orphaned worlds with no sun to call home. The galaxy doesn't sleep. It doesn't pause. It doesn't rest. It simply exists, moving according to the laws of physics, evolving across timescales too vast for human minds to fully grasp. And yet, here you are, a part of it, resting for a few hours before you wake and continue your own small but real journey through space and time. The galaxy turns. You rest. Both are part of the same grand motion. Both belong here. Both have a place in the cosmos. There's no contradiction. The universe includes both the eternal and the ephemeral, both the vast and the intimate, both the motion of galaxies and the stillness of sleep. While you sleep tonight, the Earth will rotate about 15 degrees. The Moon will move perceptibly in its orbit. The Sun will travel thousands of kilometers through its galactic path. Distant stars will explode that we won't hear about for thousands of years. New worlds are forming. Old worlds are ending. And through it all, the grand machinery of the cosmos continues, indifferent to our awareness, beautiful in its mindless dance. You don't need to stay awake to witness it. You don't need to keep vigil. The universe will take care of itself. You can rest. You can let go. You can sleep peacefully, knowing that when you wake, the stars will still be there, still shining, still turning, still ancient and patient and eternal. You are a temporary arrangement of stardust. The atoms that make up your body are ancient beyond comprehension. They've been here since shortly after the Big Bang, cycling through generations of stars scattered across light years by supernova, gathered by gravity into new clouds, condensed into planets, and eventually arranged into you. For a few decades, maybe a century if you're lucky, those atoms are organized in this particular pattern, thinking, feeling, experiencing, wondering about their own origins. Eventually, inevitably, they'll separate again, return to the Earth, become part of soil, of water, of air. Perhaps billions of years from now, they'll be incorporated into new stars or planets or life forms we can't imagine. The universe is endlessly creative. It never stops experimenting with new combinations, new arrangements, new ways of organizing matter and energy. You are one of those experiments, one of the ways the cosmos explores possibility. You are a temporary arrangement, but that doesn't make you less real. It makes you precious. It makes this moment, this breath, this heartbeat, this quiet evening drifting towards sleep irreplaceable. You'll never have this exact configuration again, these exact thoughts, this exact state of consciousness. It's singular, unique, a one-time event in the history of the universe. And somehow, miraculously, you're aware of it. You can notice yourself noticing. You can think about your own thinking. You can wonder about your own wondering. Right now, in this moment, those ancient atoms are experiencing the universe through you, seeing starlight through your eyes, if your eyes are open, feeling warmth through your skin, hearing these words through your ears, wondering about mysteries through your mind. You're not separate from the cosmos. You're one of the ways the cosmos manifests, one of the forms it takes, one of the patterns it explores, one of the methods by which matter becomes aware of itself. And that's enough, more than enough. You don't need to be anything more. You don't need to accomplish anything more. You are already a cosmic miracle just by existing. Sleep well, traveler. You've drifted with me through 2 hours of the Milky Way's quiet mysteries. From the ancient halo stars to the spiral arms, from dark matter to dying stars, from the galactic center to the farthest reaches of the halo. You've heard about collisions and transformations, about invisible forces and hidden structures, about the past, the present, and the distant future. I hope some of these facts have settled gently in your mind, like dust slowly falling through space. I hope they've helped your thoughts slow and your body relax. There's no need to remember everything. In fact, there's no need to remember anything at all. These were just quiet thoughts to accompany you on your journey towards sleep. The Milky Way will still be here tomorrow, still turning, still full of mysteries to explore. For now, just rest. Let your breathing slow. Let your muscles soften. Let gravity feel gentle beneath you. You are safe. You are home. You are part of something vast and ancient and beautiful. The galaxy holds you as you sleep, as it has held countless others across billions of years. Sleep well, traveler. Good night.